Good morning, students, and welcome to this session. I believe today there is a kind of a gehma gehmi about the test that you have attempted. Prerna Rajput says the test was done like okay, not satisfied. But you will never be satisfied with the test. So when do you want to have the next test? Today itself, tomorrow morning. Okay, fine. You are going to have the test tomorrow morning. Want to have the test for the same set, or you want to have the test for the different unit? Tell me. You are going to have the test tomorrow itself. बता दो इसी टॉपिक का लेना है दूसरे टॉपिक का करना है हम्म आवाज आ रही है ना मेरी तुम्हें आर यू एबल टू हियर मी तीर्थराज मुखर्जी बॉन्ड के ऊपर बेटा सबके ऊपर मिल जाएगा तुम्हें टेस्ट बहुत सिंपल टेस्ट था अभी मैंने आपका टेस्ट पूरा एनालाइज नहीं किया है टुडे इवनिंग वी आर गोइंग टू एनालाइज दिस टेस्ट ऑल द पीपल आई वुड सजेस्ट दैट यू complete the test by today evening so that we can analyze the test and whoever has not joined the the telegram and the whatsapp group please join the telegram and the whatsapp group so that I can send you the link there. Is that clear? Akshay Thakur, we are going to have the test of so many units. I have all the units with us. One by one, we are going to do it. Okay? Clear? एक ही दिन में तो सारे नहीं हो सकते ना जिसने लाइक नहीं किया जल्दी से लाइक कर दो एंड वी आर गोइंग टू बिगिन ओवर विद मेटलर्जी दिस बॉन्डिंग एंड मॉलिक्यूलर स्ट्रक्चर कुछ टॉपिक हमें करने हैं ठीक है ना so that's what we have as Elixir dropper batch and you can use the code AV live अब तक ग्लव्स लगा लूं मैं बेटा क्या कर सकते हैं सबके क्लासेस होनी ही होनी है और जब सबकी क्लासेस होनी ही होनी है तो कुछ ना कुछ क्लासेस तो मिस होनी भी होनी है ठीक है ना can't help it so Elixir batch is going to start from 16th of August and it will start from 16th of August that is the organic chemistry batch which is going to start initially okay Priyanshu 23 तक कर लिया तो कोई बात नहीं बढ़िया है so this is what we have as Elixir dropper batch use the code AV live कांट हेल्प इट अनन्या कहीं ना कहीं तो टाइमिंग क्लैश करेंगे ही करेंगे अब मैं सारे बैचेस की तो क्लैश की टाइमिंग नहीं चेक कर सकता ना अब 4 बजे मेरा फिक्स्ड है अब ये तो पंखुड़ी मैम ने रख दिया okay you can join with the Elixir batch you can get all the information from 6366950786 and that's me so let's get along with the VSEPR and we were talking about the triatomic molecules so we talked about something like triatomic molecules. And the triatomic molecule that we talked about initially was the first molecule was BeCl2. Now here we have talked about certain information about BeCl2. Let's get along further. And अगर आपको कुछ भी पूछना है तो पूछ लेना without any confusion, without any drawbacks. सीधा सीधा पूछ लेना so that I will be able to answer you clearly. ठीक है हम गप्पे हिंदी में मारते हैं पढ़ाई अंग्रेजी में कर रहे हैं होपफुली सबको समझ में आ रहा है so when we talk about BeCl2 we have 3 atoms we have one chlorine another beryllium another chlorine so when we talk about this let's talk about the capacity. In yesterday's class, I told you that if we have less electronegative element, then the capacity of every atom becomes 8. Okay? Whether it be the third period element or it may be the second period element, the maximum capacity becomes 8 because beryllium is less electronegative as compared to chlorine. To expand the valency, more electronegative atom must be attached. Is this clear? Okay. So when we talk about chlorine, the capacity is 8. Beryllium, the capacity is 8. Chlorine, the capacity is 8. The electrons present in case of chlorine are 7. Beryllium are 2. Chlorine are 7. So if we talk about vacancy, chlorine has 1, beryllium has 6, and chlorine has 1. Okay. Now, here I introduce another word. Now remember this word, peripheral or terminal atoms. Peripheral or terminal atoms. What are peripheral or terminal atoms? Atoms to which only one other atom is attached. So in this case, chlorine becomes the peripheral or the terminal atom. Both the chlorines are peripheral or the terminal atoms. Hello, Ratndeep Kore. Beta, you are not regular. Sometimes you are in the class, sometimes you are not. Okay? You have to be regular in this class to take the maximum benefit. Otherwise, you won't be able to take the maximum benefit of these classes. Okay. Ananya Sarkar, I'll give you the test once again of basic concepts of chemistry and chemical kinetics. Okay? And the test is going to be tomorrow. I cannot wait for it for a long time. ये कोई आंसर नहीं होता कि सर मत ऑर्गेनाइज करो हम तैयार नहीं है. You should have prepared along with the sessions which were going on. अनन्या इस तरीके से नहीं रुका जा सकता बेटा. अब आप खुद ही देखो ना, दिस इज August, September, October, November, December, January, February, March, April. So you are left over with 9 months, considering that you are a dropper and you have to complete 30 chapters of chemistry, 30, 38 or 48 chapters of biology, and near about 28 chapter of physics. There are 96 chapters, isn't it? You can attempt this test again. That is not a problem. You can attempt this test any number of times you like. So that is not a confusion. You can attempt it. Nobody is going to stop you from that. Okay. So we can say that the life is pregnant with the result. After 9 months, you are going to get a result. So let's see what result you get. The result is going to depend on your efforts. So make the efforts and don't give an excuse. Don't worry, nobody is going to be at a disadvantage. If you want to attempt the paper once again, go ahead and attempt it. Nobody is going to stop you, and you can improve your rank every time. But you need to have more tests, isn't it? 40 questions are enough? Or should I have more questions or less questions? Tell me that. Okay, now, here we talk about the peripheral atom. And today we are going to have a Google Meet session in which we are going to discuss the test. Is that clear? You are going to get the link of Google Meet very soon. And I do have your email IDs also. I can actually send you the personal invite. But I believe this time we are not going to talk about the personal invite. We are only going to talk about the normal invite. Okay, and we are going to discuss personally, each and every person, how they have attempted the paper and how they have decided what exactly are their result, where you are lacking, where you are doing. Okay, chalo. Now we need to understand that first requirement of peripheral atoms is satisfied. So whenever you are making the Lewis dot structure, first of all, you have to satisfy the requirement of the peripheral atom, because peripheral atom cannot get the electron from anywhere else. They have only one atom to get the electrons from. So the first of all, we are going to satisfy the requirement of the peripheral atoms. Okay. Whoever has not liked the session, go ahead and like it. There are 14 watching and 11 likes. So we need to have more likes than the number of atoms. So what we do is we have chlorine, we have beryllium, and we have chlorine. So beryllium contributes one electron to both the chlorines so that their requirement is satisfied. Okay, done. Now what happens is chlorine is a member of third period and beryllium is a member of second period. There is a lot of energy difference and the size difference between the orbitals. So chlorine is unable to contribute additional electron to beryllium. Okay, although beryllium has the vacancy, but chlorine is not able to contribute the electron effectively. Fine. So Cl being the member of third period is not able to contribute additional electrons. So chlorine is able to contribute only one electron. Now this is the problem with chlorine, not beryllium. Okay, so chlorine, this is going to be the arrangement. This chlorine, this is going to be the arrangement. This is the influence of chlorine. This is the influence of this chlorine. And this is the influence of beryllium. Now here it becomes a single bond. Here it becomes a single bond. And beryllium still has vacancy of 4 electrons. Now this beryllium happens to be having a vacancy of 4 electrons. It has 4 electron places empty. It is electron deficient. So it is called electron deficient. Okay. Such species which have electron deficiency, that is, they have capability of accepting the electron pairs in addition to what they have, they are called Lewis acids. Species having capacity to accept electron pair. Those are termed as Lewis acid. Now, beryllium chloride is a Lewis acid. Any confusions, anybody? Contribute, वो मैंने थोड़ा सा ऐसे ही उड़ा के रख दिया. Anyone has any confusion about Lewis acids? Now, when we talk about the beryllium chloride, understand that beryllium chloride having the deficiency, what actually it does. Here we have the beryllium, here it is chlorine, here it is chlorine, here we have another chlorine, here we have beryllium, And here we have chlorine. This is the normal bond. 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 And beryllium actually accepts an electron pair from the chlorine, forming a coordinate bond. Okay, so this becomes a coordinate bonded dimer. So as you can very well see, beryllium actually tries to satisfy its vacancy by accepting the electron pair from beryllium, from chlorine. Okay, chlorine, although was not able to form a coordinate bond in addition to the sigma bond, but it is able to form the coordinate bond with another beryllium. Okay, and what happens is this is in the vapor phase. Vapor phase, it's a dimer. But in actually solid and liquid phase, what happens is this beryllium is there. Here we have chlorine, chlorine. Here we have again, this is beryllium, this is beryllium. And here we have the chlorine forming a twisted structure. This structure of beryllium chloride is going to be there. So what we have, beryllium chloride, here it's going to be something like this structure. This is going backward. This is Cl, here it is Cl, and here this is going front. So that is the structure of beryllium chloride. Okay, just a minute. Let me see if I have the structure of beryllium chloride or not. सॉरी वो मैं गलती से उसका स्टॉप स्ट्रीमिंग हो गया था. Now this is the structure of beryllium chloride. I was just searching for beryllium chloride, and when I pressed the button 2, then in that case started streaming. So this is the structure of beryllium chloride. Can you very well see it? So this is a coordinate bonded polymer. Coordinate bonded linear polymer. So that's what we have as beryllium chloride. Is that clear? The coordinate bonded linear polymer, the beryllium chloride polymer. Okay? जीते रहो बेटा नारुतो, हाउ आर यू? कभी आते हो, कभी नहीं आते हो, कहाँ रहते हो? So fine, that was beryllium chloride, and now let's get along with something called carbon dioxide. Or rather carbon dioxide, beryllium chloride we have understood. Now there is one thing more which we call as the steric number. We have talked about the peripheral atoms. We have talked about something else. We have talked about the structure. Now let's talk about the steric number. Steric number is the sum of lone pairs and number of atoms attached to a given atom. So steric number is the sum of the lone pairs and the number of atoms attached to a given atom. Okay. Please understand what we are doing is we are going sequence wise and we are going quite certain things. जो भी चीज की जहां जरूरत है, I am defining it right there. Okay. अब जैसे कि steric number यहां पर आ गया है. So this is what we have as steric number. Steric number is the sum of the lone pair and number of atoms attached to a given atom. Most important, steric number is of an atom and not a molecule. ठीक है? Different atoms in a molecule can have their own steric numbers. Is this clear? And a very important thing, we do not find steric numbers of peripheral, that is terminal atoms. We do not find steric numbers of peripheral or terminal atoms. Okay. अब किसी को प्रॉब्लम स्टेरिक नंबर में? किसी ने कुछ पूछना है? Anything about the steric number? ठीक है. Now, once we talked about what is a steric number, how we talk about the terminal atoms, कि terminal atom के steric number की बात हम नहीं करते. What is the steric number used for? Steric number gives the preferred orientation of the atoms and lone pairs around an atom. Okay. So if the steric number is 2, then the preferred angle between the lone pairs and the atoms would be 180 degrees. Because the lone pairs, the atoms, the electrons, they repel each other. And when they repel each other, they would like to be at the maximum distance from each other. The maximum distance translates into maximum angle. And maximum angle here would mean 180 degrees. Okay. So the observed geometry will turn out to be linear. So if we have the steric number as 2, then in that case, the observed geometry and the angle between the electron pairs is going to be 180 degree. It's going to be linear. Any confusions? Fine. Now let's talk about some other steric number as well. If the steric number is 3, the preferred angle is 120 degrees. And the geometry becomes trigonal planar. Okay? If the steric number is 4, the preferred angle becomes 109 degree 28 minutes, which generally written as 109.5 degrees. And the geometry becomes tetrahedral. The geometry becomes tetrahedral. If the steric number is 5, then in that case there are two preferred angles. It's 120 degrees, it's 90 degrees, and it's 180 degrees. Okay? There we can't have single preferred angle. We are going to make these structures, we are going to understand a little bit more about it, and then it becomes trigonal bipyramid. If the steric number turns out to be 6, the angle is 90 degrees and 180 degrees, and it is called an octahedron. If it is 7, it becomes 72 degrees, it's 90 degrees, it's 180 degrees, and it is called pentagonal bipyramid. Note down this table. It's an extremely important table. And what we have just done is called VSEPR. This is valence shell electron pair repulsion theory. Distorted octahedron? Which one is distorted octahedron? We are talking about the geometry, preferred angles. We are not talking about what angle actually will be observed. We are talking about the preferred angle. Okay? So that's what we have a steric number. So when we talk about beryllium chloride, the steric number is equal to 2. So beryllium chloride is actually linear. Seven one is not distorted octahedron beta, it is pentagonal bipyramid. 7-1 is distorted octahedron when we have a lone pair. That is XeF6. Don't get confused in it. Is this clear? So now let's talk about another example. And let's talk about the example of carbon dioxide. CO2. So we have oxygen, we have carbon, we have oxygen. This is CO2. Tirthraj, we are not talking about hybridization as yet. We are not talking about hybridization as yet. Okay. We'll talk about it a bit later. Okay. So here we have the CO2 structure, carbon dioxide. Now let's talk about the capacity first. Capacity 8, 8, 8. The electrons present 6, 4, 6. Okay. Vacancy 2, 4, 2. Okay. Now, oxygen are peripheral atom, oxygen are the terminal atom. So first of all, we have to satisfy the vacancy of oxygen. Let's go ahead and satisfy the vacancy of oxygen. No confusions with that. Okay. So here we have the vacancy of oxygen satisfied by the carbon. Here the vacancy of oxygen is satisfied by the carbon. Done. Now I need to satisfy the vacancy of carbon. What we can do is there are more than one ways actually. There are more than one ways to satisfy the vacancy of carbon. Now let us see how we can satisfy it. One way would be that we take two electrons from this oxygen and we take two electrons from this oxygen. Here the vacancy of oxygen is satisfied. Here the vacancy of oxygen is satisfied. And here the vacancy of carbon is satisfied. Is this clear? Now here the structure can be represented like this. That's the structure of carbon dioxide. Anyone has any problems? Now let's say we talk about the steric number. Carbon steric number is 2. The geometry preferred is linear. Somebody asked me why carbon dioxide is linear. I believe the answer is there. किसी ने पूछा था मुझसे कि कार्बन डाइऑक्साइड लीनियर क्यों होता है, तो अब पता चल गया आपको कार्बन डाइऑक्साइड लीनियर क्यों होता है. ठीक है. Now there is another way of writing it. We have an oxygen, we have the carbon, we have another oxygen. Now let's talk about the electron. There is no way carbon has to give two electrons to both the oxygen. इसमें कोई ifs and buts नहीं है, ये तो ऐसे ही होगा. But when carbon accepts the electron, is it necessary that it has to take two electrons from one oxygen? Can't it take four electrons from one oxygen? Is it not possible? Anything wrong with it? Can't it take four electrons from one oxygen and zero electrons from other oxygen? Satisfy तो फिर भी हो रहा है. हाँ भाई, कोई प्रॉब्लम? And now this would be having this kind of a structure. This oxygen is going to have a negative charge and this oxygen is going to have a positive charge. So this becomes another structure for carbon dioxide. And there could be another structure in which other oxygen is going to have the electron. सुमित्रा, इसमें 3D कहां से? लीनियर स्ट्रक्चर में 3D क्या करोगे? तो 1D है. 1D में 3D कहां पहुंचा रहे हो? This is simply one-dimensional, linear. Sumitra, we are not talking about stability. We are talking about possibility. Do you always do the things which are most stable and most logical? Have you never done illogical things? Have you never done the things which you know are going to harm you? So, why can't molecules do it? Now, carbon dioxide can have three structures in which the atoms retain their position, but the electrons shift. Okay. These structures of the same molecule in which the atoms retain their position but the electrons shift are called resonating structures or canonical structures. Okay. The structures in which atoms, structures of the same molecule, I should say, of the same molecule in which atoms retain their position, but there is a shift of electrons. You may call it bonds, charges are termed resonating or canonical structures. Okay, so these are resonating or canonical structures. जीते रहो बेटा आतिफ कैसे हो So that's what we have as resonating or canonical structure. That is what we have as the bond. And that's what we have as carbon dioxide to three structures, resonating or canonical structures. Fine? Yes, four bonds, three atoms, two peripheral atoms. नहीं बेटा राधिका ये हाइपर कॉन्जुगेशन नहीं है हाइपर कॉन्जुगेशन भी रेजोनेंस है लेकिन एवरी रेजोनेंस इज नॉट हाइपर कॉन्जुगेशन ठीक है existence of canonical structures is termed resonance. All the best, Atif. Clear? So this is what we call as resonance. Any confusions, anybody? So let's have another example. Let's have the example of OCN minus. This is cyanate ion. Cyanate ion. Okay. So we have O, we have C, we have N. Clear? Here we have the capacity. Now, please remember this part, which I'm writing capacity, the number of electrons present, the vacancy. Nobody's actually writing it. No book ever mentions this. No book ever tells it because it's considered, yeah, ये तो आता ही होगा. ठीक है? But please remember, I am teaching according to the students who really do not know chemistry, but they want to get 180 on 180 in chemistry, even if they don't know it. So I'm starting from very basics and I'm starting from very simple things. I'm telling you step by step procedure, what later on is going to go on in your mind only. You are not going to write it. You are just going to do it in your mind. ये सारा का सारा दिमाग में होगा, लिखना नहीं है इसको. Okay. So we have the capacity. Oxygen has capacity of 8, carbon has 8, nitrogen has 8. Okay. Because they all are second period elements. Now, present electrons. Oxygen, it is 6, carbon, it is 4, nitrogen, it is 5. But important thing is that there is a negative charge also. So if you talk about the negative charge, then in that case, you have to put the negative charge on some atom. किसी atom पे तो डालोगे. Clear? Now, carbon is the least electronegative. I told you the negative charge is to be put on more electronegative atom. And you get a choice. Choice क्या है? Oxygen or nitrogen. Oxygen and nitrogen both are more electronegative than carbon. Quite obviously, it is better to put on oxygen because oxygen is more electronegative than nitrogen. But still, there is a possibility that negative charge can be on nitrogen also. Okay? So where are you going to put the negative charge? चलो एक काम करते हैं, दोनों पे डाल के देख लेते हैं. एक बार ऑक्सीजन पे डाल देंगे, एक बार नाइट्रोजन पे डाल देंगे. ठीक है? तो हम एक और स्ट्रक्चर बना लेते हैं. Wherein again we have oxygen, carbon, and nitrogen. Here we have 8, 8, 8. Here we have 6, 4, 5. In this case, we put a negative charge on nitrogen. Let's say we put it on nitrogen. Okay. And here we put the negative charge on oxygen. समझ में आ रहा है +1 क्यों किया है? +1 for negative charge. एक केस में नाइट्रोजन पे डाल दिया, एक केस में ऑक्सीजन पे डाल दिया. ठीक है? Now let's talk about the vacancy. Now this oxygen has a vacancy of 2, carbon has a vacancy of 4, nitrogen has a vacancy of 2. Okay. Now this oxygen has a vacancy of 1, carbon has a vacancy of 4, and nitrogen has a vacancy of 3. Clear? Now let's start making the structure. Here we have oxygen, here we have carbon, here we have nitrogen, here we have oxygen, here we have carbon, here we have nitrogen. Now, carbon is the central atom. Oxygen and nitrogen are peripheral. तो oxygen and nitrogen की vacancy पहले satisfy होनी है ना? Let's satisfy the vacancy of oxygen and nitrogen. So oxygen has a vacancy of 2, carbon gives us 2 electrons. Nitrogen also has a vacancy of 2, carbon gives the 2 electrons. Is this clear? Fine. Now, let us satisfy the vacancy of carbon now. So, is your wish any way you like. Okay? Let us say we consider that oxygen gives the 2 electron. देखो एक बात बता रहा हूं कि अगर आपके दिमाग में खुराफात आ रही है और आपका तो नहीं नहीं हम तो 4 इलेक्ट्रॉन नाइट्रोजन से दिलवाएंगे, एक भी इलेक्ट्रॉन ऑक्सीजन से नहीं दिलवाएंगे, कर लो कर लो कर लो कर लो, कोई दिक्कत नहीं है, करके देख लो. ठीक है? बट आई विल जस्ट से कि जितनी पॉसिबिलिटी आपके दिमाग में आती है ना, वो सारी पॉसिबिलिटी लगा लो और देखो कितने स्ट्रक्चर बनते हैं फाइनली विद द फॉर्मल चार्ज एंड ऑल. यू विल फाइंड कि आप जितनी मर्जी खुराफात कर लो, आप 2 स्ट्रक्चर बना सकते हो, उससे ज्यादा नहीं. ठीक है? यू हैव एब्सोल्यूट फुल. सर ये क्यों नहीं हो सकता? अरे भाई हो सकता है, कर लो. क्यों नहीं हो सकता? केमिस्ट्री में नहीं होता. ठीक है भाई, सीधी सी बात है. कार्बन हैज अ कैपेसिटी ऑफ 8 इलेक्ट्रॉन्स. अब 8 से ज्यादा तुम कैपेसिटी नहीं बना सकते, वो नहीं हो सकता क्योंकि जगह ही नहीं है. और ये हमने नहीं बनाया, नेचर ने बनाया है. ठीक है? नाइट्रोजन की कैपेसिटी 8 को एक्सीड नहीं कर सकती, नहीं कर सकती. इट कैन नॉट एक्सीड 8 बिकॉज इट्स सेकंड पीरियड एलिमेंट. Carbon capacity, oxygen capacity cannot exceed 8 because it's a second period element. That you can't do. उसके अलावा तुम्हें जो करना है करो, कर लो. ठीक है? जिसने लाइक नहीं किया वो जरूर कर देना. And now nitrogen also gives the two electron, 1, 2, 3, 4, 5, 6. Nitrogen has 6 electrons because it has additional 1 electron as the negative charge. So this is our structure. And if I put the formal charge will turn out to be on nitrogen. मेरे हाथों में black black gloves है बेटा. Artist glove. I'm writing on an iPad तो वो smudge कर देता है. इसलिए पहन रखा है. Okay? And then here, what I do is, I put the negative charge on oxygen. So now oxygen has a vacancy of 1 electron and nitrogen has the vacancy of 3 electrons. Okay. So here we say that nitrogen is giving 3 electrons to carbon and oxygen is giving 1 electron to carbon. Oxygen has the negative charge. Okay. And the structure is, and these are the two resonating structure of cyanate ion. अब एक बात मजेदार सी देखोगे. The cyanate ion has the same structure, same number of electrons, same number of atoms as carbon dioxide. Same structure, number of electrons, steric number, geometry as CO2. ठीक है? So these are the species which we call as isoelectronic species. Sumit Roy, both and one of the sides mean different, isn't it? It can bond from any one side. That's what we call as ambident or ambident. Okay? Ambi. Either this or this, not both. Clear? It's ambident nucleophile, ambident ligand, ambident. One of the two, not both. ठीक है? So, OCN minus is isoelectronic with CO2. Okay? Same is the case with SCN minus. Instead of oxygen, we have put sulfur. And again, sulfur is attached to carbon, so its vacancy is not going to exceed. Sulfur again is going to have the outermost vacancy of 8. Is this clear? Isoelectronic with CO2, carbon dioxide. साफ दिख तो रहा है बेटा, इसमें कोई कंफ्यूजन तो नहीं है. साफ साफ तो दिख रहा है. Is this clear? Is that clear? चलिए, let's make another structure. NO2 plus. This is called nitronium ion. Can you make the structure of this nitronium ion? And again, you will find it is isoelectronic with carbon dioxide, cyanate ion. That's good, Teethraj. Make it structure quickly. NO2 plus and give me the formal charge. Sumit, I didn't want the hybridization. I just want the structure. That is the structure that you create. Fine? MS. बेटा हमारी स्माइल और हमारा आशीर्वाद तो बिना कुछ कहे मिलता है. ठीक है ना? आपको चांद नहीं चाहिए, आपको एडमिशन चाहिए. आपको स्माइल नहीं चाहिए, आपको रोशनी नहीं चाहिए, आपको अपना सिलेक्शन चाहिए. तो अपने सिलेक्शन और अपने मार्क्स के लिए वर्क करो. स्माइल और आशीर्वाद तो मिलता ही रहेगा. उसमें क्या है? ठीक है, चलो मेहनत करो और मुझे N3 माइनस एजाइड आयन का स्ट्रक्चर बना के दो. Quickly make the azide ion structure and its resonating structures. MS बेटा MS से कुछ पता नहीं चलता ना. So what exactly are you doing now? MS azide ion का स्ट्रक्चर बताओ बेटा. Azide is NNN. You have to put the negative charge on one of the nitrogen and then you have to make the structure. Give me the formal charge as well. You will find that you will be able to make two structures. One structure would be N, 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 double bond, नेगेटिव नेगेटिव एंड पॉजिटिव, एक ये स्ट्रक्चर बनेगा और दूसरा स्ट्रक्चर ये बनेगा. समझ आ रहा है ये? That's nitronium ion and the azide ion. Is this clear? So let's have another ion and another species, N2O, nitrous oxide. Okay, remember N2O is not NON, N2O is NNO. Now solve it. N3 माइनस बेटा वो पेरिफेरल एटम है अक्षय ठाकुर. एक एटम का स्टेरिक नंबर है, इसमें किसका स्टेरिक नंबर 4 बना दिया आपने? किसी का भी स्टेरिक नंबर 4 नहीं है, स्टेरिक नंबर इज 2. सेंट्रल एटम द स्टेरिक नंबर इज 2. There are again two structures possible. One is this, another one is this. Any confusion? मैं फ्रीज हो गया? कैसे फ्रीज हो गया? नहीं नहीं, मैं चल रहा हूं. Okay, so that's what we have as nitrous oxide. That's what we have as carbon dioxide. That is what we have as these structures. So we have talked about the triatomic molecules having the steric number 2. So all these molecules have the common thing that they have the steric number of 2. They all are linear. They are all triatomic molecules. Any confusions? Now let's talk about something like O3, ozone. Ozone की बात करें. Now ozone is OOO. Make the structure. स्टेप वाइज चलोगे कोई दिक्कत नहीं आएगी. अगर जल्दबाजी करोगे, टाइम बचाने की कोशिश करोगे, फंस जाओगे. बताओ ओजोन का स्ट्रक्चर. अगेन यू विल बी एबल टू मेक टू स्ट्रक्चर्स ऑफ ओजोन. दो स्ट्रक्चर बन जाएंगे. एक स्ट्रक्चर बनेगा ये. ओके. और दूसरा स्ट्रक्चर बनेगा ये. इंपॉर्टेंट बात यह कि दोनों आइडेंटिकल स्ट्रक्चर्स हैं, फर्क ही नहीं है कोई. बस पलट दिया है. And the important thing is the steric number here comes out to be 3. One lone pair and two atoms. Both the atoms which are attached are of oxygen. Thank you, Suga. Now, geometry is trigonal planar, but one of the position will be occupied by the lone pair. So here we get the structure like this, and another one resonating structure like this. Okay. And now we get something called resonance hybrid. And resonance hybrid is going to be this. Okay. So we have something called resonance hybrid, a combination of all resonating structures. That is a single structure representing all resonating structures. Okay, permanent permanent bonds are represented by solid lines. Optional bonds represented by dotted lines. Is it clear? ठीक है ज्योमेट्री तो हमारे पास ट्रायगोनल प्लेनर है but the shape or structure that we get is going to be bent or angular. ठीक है so this is what we have as the resonance hybrid. Is this clear? Any confusions? That's what we have as ozone. ठीक है let's say the first structure that we make is BF3. हाँ सुमित्रा NO2 माइनस भी देखेंगे तब देखेंगे पहले जरा BF3 देखें now when we talk about BF3 it is going to be like this And now very clearly understand that there is a back bond from the side of fluorine to boron. Okay, there is a back bond. Why there is a back bond? Because fluorine and boron belong to the same period. They have similar size of the orbitals, so fluorine is able to donate the electron to boron. So BF3 actually has this kind of a structure. Okay, it is a regular trigonal planar. I believe we are doing this chapter in a very high detail. Everything is absolutely clear. कोई confusion तो नहीं है किसी को भी? Rainfall in Chandigarh. Good. This is 120 degrees. And this is what we have as resonance hybrid. Is this clear? Okay, then this is BF3. Now let's talk about something like CO3 2 minus. Could we make the structure of CO3 2 minus? टेक योर टाइम, आराम से बनाओ, तुक्केबाजी में नहीं, रट्टा मार के नहीं, समझ के बनाओ. क्रिएट द स्ट्रक्चर अंडरस्टैंडिंग के साथ. बेटा हाइब्रिडाइजेशन नहीं पूछ रहा हूं, स्ट्रक्चर बनाना है आपको। कॉपी पे स्ट्रक्चर बनाओ कार्बन डाइऑक्साइड का, कार्बोनेट आयन का। यहां पे कार्बन है, ये ऑक्सीजन है, ये ऑक्सीजन है, ये ऑक्सीजन है, एंड वी हैव टू नेगेटिव चार्ज। आपको जहां नेगेटिव डालना है डालो, कोई दिक्कत नहीं है। ठीक है। माय सजेशन इज कि दोनों नेगेटिव एक ऑक्सीजन पर मत डालना। डाल भी दोगे तो भी कोई फर्क नहीं पड़ने वाला। फिर तुम खुद कंफ्यूज होगे कि अरे ऑक्सीजन का तो वैलेंसी पूरी हो गई, तो फिर वो बॉन्ड इलेक्ट्रॉन दे क्यों रहा है या एक्सेप्ट क्यों कर रहा है। सो इसलिए दोनों ऑक्सीजन पे एक एक इलेक्ट्रॉन डाल दो, कोई भी दो ऑक्सीजन पे। ठीक है। So let's say we put a negative charge here, we put a negative charge here. This oxygen is going to have 7 electron. This oxygen also is going to have the 7 electron. This oxygen is going to have the 6 electron. Carbon has 4 electron. Carbon has a vacancy of 4. Now carbon has to satisfy the vacancy of all the three oxygens because that is the central atom and the oxygens are terminal or peripheral. तो कार्बन एक इलेक्ट्रॉन इसको देगा, एक इलेक्ट्रॉन इसको देगा, दो इसको देगा। अब दो इलेक्ट्रॉन इससे ले लेगा, एक इलेक्ट्रॉन इससे ले लेगा, एक इलेक्ट्रॉन इससे ले लेगा। ये हमारे पास कार्बोनेट आयन का स्ट्रक्चर बन गया। ठीक है ना। क्लियर। सो लेट्स मेक द थ्री स्ट्रक्चर्स। तो कार्बोनेट आयन के तीन स्ट्रक्चर बनेंगे, एक ऐसा, एक ऐसा और एक ऐसा। So resonance hybrid would be, now each of these is going to have a charge of 2 by 3 minus, and this bond is going to be 4 by 3 bond. पेरिफेरल एटम्स में -2/3 का बॉन्ड ऑर्डर नहीं बेटा, -2/3 का चार्ज। अक्षर अक्षर थिंक अगेन। Any confusions? Now let's get along with nitrate ion. Nitrate and carbonate again are isoelectronic. Nitrate, carbonate, BF3, they are again isoelectronic. चेक करके देख लो. नाइट्रेट का जो रेजोनेटिंग स्ट्रक्चर फाइनली बनेगा, दैट वुड बी ये नाइट्रेट का रेजोनेटिंग स्ट्रक्चर बनेगा. अच्छा, SO3 का भी बना लो. अब SO3 में एक छोटी सी ट्विस्ट है. S कैन एक्सीड 8. तो SO3 का मेन स्ट्रक्चर कुछ ऐसा बन जाता है. स्टेटिक नंबर अभी भी 3 है. Geometry is again trigonal planar. Angle is again 120 degree. Akshay, there is no coordinate bond, beta. You have just to talk about bonds. Coordinate bond bolna hai, bol lo. NCERT doesn't talk about coordinate bonds. Is this clear? Hello, fun and masti with biology. जीते रहो बेटा. ओके. चलो SO2 का बनाए और NO2 माइनस का. एनी कंफ्यूजन एनीबॉडी? कुछ पूछना है इनमें? Now let's talk about something called CH4. कोई दिक्कत? और बताओ. So this is what we have as a tetrahedron. And could we make it of SO4 2 minus? अब जितने भी मॉलिक्यूल आप सोच सकते हो सबके स्ट्रक्चर बना लो. ठीक है? और शाम को मिलते हैं 4 बजे एंड वी आर गोइंग टू टॉक अबाउट द हाइब्रिडाइजेशन. क्लियर? जितने भी एटम्स, जितने भी मॉलिक्यूल्स वी हैव ऑलरेडी क्रिएटेड, वी आर गोइंग टू टॉक अबाउट देयर हाइब्रिडाइजेशन एट 4 p.m. Is it clear? 2 o'clock, you are going to have botany class with Swati Batra ma'am. You are going to have a zoology class at 3 p.m. with Sachin sir. And 4 p.m. you are going to get a chemistry class with me once again, where we are going to talk about hybridization. Clear? So join the Telegram channel for YouTube classes and PDFs. t.me/NEET Elixir. I hope you have created your notes for this session. Download the Unacademy app and join with us. Okay, this is my page on Unacademy. Join with it for the best live session, live classes. Bye-bye, take care. और टेस्ट पेपर वी हैव टू डिस्कस इन द इवनिंग. तो जिसने भी टेस्ट नहीं दिया है, टेस्ट जरूर दे देना, जिससे कि हम उसको आराम से आपके साथ डिस्कस कर सके. जो भी कर सकते हो, जो भी जितना भी कर सकते हो उतना करो. पता तो चले आप कहां लैक करते हो, क्या आपको आता है. मे बी यू आर थिंकिंग दैट यू डोंट नो एनीथिंग एंड यू माइट बी नोइंग अ लॉट ऑफ थिंग्स. ठीक है? बाय बाय, टेक केयर.